In this video, we're going to learn about adding rational expressions with common denominators. So what is a rational expression? It's a fraction with both constants and variables. And common denominators mean that the denominator or the bottom part of my fraction is going to be the same, and the top parts are going to be different. So we're going to talk about how to add those together. So I just wanted to review with you, though, how to add a fraction. So when we add a fraction, we first want to make sure that we have a common denominator. In this lesson, all of our fractions will have common denominators, so we will know that that step is automatically true. The next, what we're going to do is we're going to add the numerators, or the tops of the fractions. And we want to remember that when we add our fractions, we only want to add together the like terms. So remember, like terms are terms, things that are added or subtracted to each other that have the same exact variables, but maybe the numbers in front of the variables are different. And then we're going to reduce or simplify our fractions as much as possible. So just a quick reminder. So down here on this first example, 2/3 plus 5/3, my denominator is the same. So when I add a fraction together, my denominator stays 3. I don't do anything to it, and I add together the tops. So this becomes 2 plus 5 all over 3, and 2 plus 5 is 7. So this answer would be 7/3. Same thing over here when I have variables in my denominator, 6w and 6w. Again, my denominator is the same. So my denominator stays 6w, and then I add together my tops. In this case, I'm subtracting 5 minus 9. 5 minus 9 is -4 over 6w. And then I would reduce my fraction. I would ask myself, is there a number that goes into 4 and 6? Well, yes, there is. 2. 2 goes into 4 2 times, because 2 times 2 is 4. And 2 goes into 6 3 times, because 2 times 3 is 6. So this actually reduces to -2 over 3w would be your final answer here. So that's what it means to reduce or simplify. Okay, now we're going to make it a little bit harder in the denominator with some more expressions. The rules are the same, even though I have expressions in the numerator and the top, which is the top, and the denominator, which is the bottom, but my rules stay the same. Is my denominator the same? Add together the numerators and simplify. So I'm going to look here and say, yes, I have a common denominator. It's both 2c. Here's something you want to watch out for. This is tricky. This negative out in front means the whole fraction is multiplied by -1. So I'm actually going to rewrite this to show that this is -1 times 6c minus 12d, all divided by 2c, plus 4c minus 9d, all over 2c. Because what happens is this -1, I have to distribute. It changes the sign of everything here. So this becomes -6c minus 12d, all over 2c, plus 4c minus 9d, all over 2c. So my denominators stay the same. I'm going to shrink this down a little bit so I don't run out of space here. So my denominators stay the same. Because they're 2c for both of them, I'm going to make one big fraction. And I'm going to write the whole thing that I'm adding together. I'm going to combine the numerators together. So I have -6c plus 12d plus 4c minus 9d. Now, I have to look in my numerator and see, do I have like terms? So here I have c's, and here I have c's, and here I have d's, and here I have d's. So I'm going to combine those together. I'm going to move this up here. Again, my denominator stays the same, 2c. So how many c's do I have? -6c plus 4c gives me -2c's. Remember, I'm adding the terms, the numbers next to my variables. So what's -6 plus 4? -2. And then I have 12d minus 9d. So I do 12 minus 9, and that's going to give me 3. So this is going to be plus 3d. There is no number that goes into all three of these all three here, negative 2, 3, and 2. So this is my final answer. Let's try another one. Okay, so again here, watch out because I'm subtracting. So that's really like a negative 1 times this whole fraction. So I'm going to rewrite this. 2x minus 11y over 8x plus negative 1 times 9x minus 9y over 8x. I'm going to distribute this negative 1. It changes the sign of everything. So I have 2x minus 11y over 8x plus negative 9x plus 9y all over 8x. Now, because my denominators are the same, I'm going to combine it together in one big fraction with my denominator 8x. And I'm going to combine the numerators and write them all in one line. So I have 2x minus 11y plus negative 9x plus 9y. And I want to look for my like terms. So here I have x's, here I have x's, here I have y's, and here I have y's. So my denominator again is 8x. Okay, my x is on the top. I have 2 minus or plus a negative 9 is going to give me negative 7x. And negative 11y and 9y gives me negative 2y's. There is no number that goes into negative 7, negative 2, or 8. So this is my final answer. Okay, we're making it a little bit trickier. This time, you'll notice I don't have any subtractions. I'm just adding here and there's no negative out in front. So I can say, cool, my denominators are both the same. So I'm going to put my 4x in the denominator. I'm going to write my whole numerator together. So I have 7x plus 1 plus 9x minus 5. I have x's here. I have x's here. I have a constant here and a constant here. So I combine together. 7x plus 9x is going to give me 16x. And 1 minus 5 is going to give me negative 4 divided by 4x. Okay, so now there is a number that goes into 16 and negative 4 and 4. And really what you want to do is look at just the numerator. Is there a number that goes into both 16 and 4? Yes, there is. So we're going to factor it out. What number goes into 16 and 4? 4 does. 4 is the biggest one that goes in there. So I'm going to take out a 4. 4 times how much is equal to 16? X? 4x. 4 times how much is negative 4? Negative 1. And then my denominator stays the same, divided by 4x. Okay, now since I factored that out, I can now cancel these because they are groups. When you're canceling in expressions like this, you can only cancel things that are multiplied. This move right here is totally illegal. You cannot do this. Oh, well, this cancels with this and this becomes 4. You can't do that because 16 minus 4 is a group. When you're canceling in fractions with expressions, which means it's going to have variables and numbers, you have to only cancel groups. And groups are things that are multiplied together. So now over here that I'm multiplying 4 times 4x minus 1. This 4 is a group and this 4x minus 1 is a group. Okay? Down here, things that I'm multiplying I can cancel. So I will have a 4 and an x on the bottom and a 4 and a 4x minus 1 on the top. So these are ones that I can cancel. So my final answer is 4x minus 1 over x. Okay, last one. This is a little bit even harder. Now we're bringing in things where I actually have to factor a quadratic. Okay, so first thing I want to check though is my denominator the same, c squared plus 6c plus 9, good. C squared plus 6c plus 9, perfect. Okay, so my denominator is the same. Here I have a subtraction, but I only am subtracting this guy. So it's just going to be minus 15. So I'm going to write out everything I have. I'm going to move this down actually a little bit more. So I have c squared plus 6c plus 9. And on the top, I have c squared minus 2c minus 15. Now, when you're dealing with quadratics, you have to first factor each expression, and then we're going to try and cancel groups. So over here, I'm going to factor c squared minus 2c minus 15. So the easiest way to factor, I like to use the giant plus, but I'm going to kind of help you out on how this works. So when I'm factoring, I want to multiply, I want to multiply to negative 15, but I want my numbers to add to negative 2. So I'm going to take my factors of negative 15. What multiplies to negative 15? Well, positive 1 times negative 15 and negative 1 times positive 15. Does 2 times anything equal 15? No. 3 times 5, so 3 times negative 5 and negative 3 times positive 5 equal 15. If I'm going to go down the list, 4 times anything equal 15? Nope. Does 5 times something equal 15? Yes. And if I write a 5 here, I know I'm going to get a 3 here. And now see how I have repeated factors 3 and 5 and 3? That means once I start repeating my numbers, I have all my factors. So of these factors, we have 1, 2, 3, 4. Which of them add up to negative 2? Well, 1 plus negative 15, I'm going to add these together, equals negative 14. This equals positive 14. This is negative 2, and this is positive 2. So these ones add to negative 2. So when I do my giant plus, what goes here in this first part is what multiplies to c squared. Well, I know that c times c is c squared. What goes here in this, in this second part is what multiplies to negative 15 but adds to negative 2, and we figured that out, that was 3 and negative 5. So I'm going to multiply across. C times 3 is 3c, and c times negative 5 is negative 5c, and I'm going to add these together. 3c plus negative 5c is negative 2c, just to make sure I did it right. This number right here should match this number right here, and that's what I want. So my factors are c minus 5 and c plus 3. So I'm going to write them out. C minus 5 times c plus 3. Okay, so now that I have that factored, I'm going to come up here and I'm going to cross this off and say, well, I know this is the same as c minus 5 times c plus 3. Now I want you to try and factor the bottom. Okay, so now's a good time to stop the video and factor the bottom. So we're factoring c squared plus 6c plus 9. So I'm going to write this down here. Okay, so we want to multiply to 9 and add to 6. So what are my factors of 9? Well, 1 times 9, negative 1 times negative 9. We have 2 times nothing is 9. We have 3 times 3 is 9, or negative 3 times negative 3 is 9. 4 times nothing, 5 times nothing, 6 times nothing, 7 times nothing, 8 times nothing, and 9 times 1. So these are all my factors. So now I want to know what adds to 6. 3 plus 3 is equal to 6. So when I do my giant plus, what multiplies to c squared? That goes here. C times c. What multiplies to 9 but adds to 6? That goes here. 3 times 3. I'm going to check. I'm going to multiply across these guys. C times 3 is 3c. C times 3 is 3c. I add them together and I should get 6e. This should match my middle term, which it does. So my factors, I cross them. C plus 3 and c plus 3. So, and I know it's plus because it's a positive number. If I go back to the other one here, where one of my numbers was negative, that's how I know it's minus instead of plus. Okay, so this factors into c plus 3 times c plus 3. And I'm going to rewrite this just so that you can see without all the crossing off. So I'm at c minus 5 times c plus 3 divided by c plus 3 times c plus 3. Now remember, you can only cancel groups. So I have two groups on the top, c minus 5 and c plus 3, and I have two groups on the bottom, c plus 3 and c plus 3. I have a c plus 3 on the top and the bottom, so this guy can cancel with this guy. So what am I left with? My final answer, c minus 5 over c plus 3. Okay, so remember, when you're doing this, you first need to have a common denominator, which in this case we do. Then you want to add together the numerators. Watch out for if you're subtracting or if you have a negative out in front of your fraction, because that means it's a -1 multiplied by everything in the numerator, and it changes the sign. And then third thing you want to do is reduce or simplify. So you want to cancel out groups. So only things that are groups that are multiplied together can you cancel out. Let me know if you have any questions. Good luck.